Okay, let me come around and check your homework.
How did you know that?
Just not that good.
Yeah, I'll hand back your quizzes tomorrow.
You got all 6 right? Oh, you can just go. I'm still missing the first 3 things.
No, I think after we get food.
I'm doing a challenge.
She's so nice about that. When she did that.
Wait,
Yeah, no, I
no,
loved
she
it.
said that she, our class, no, you guys didn't like that. I was like, bro, I had to. The entire class is screaming about it. I love you. And then she brought store stuff, and I was like, why? Like, I love your baking. You know, it's a little bit interesting. Are we not? I think it tastes like normal.
Yeah,
Dude,
yeah.
yeah.
Good.
Wait, did I
We didn't have any
Brownies.
forks.
You didn't have to.
I broke the plastic knife.
Or do we just not? Okay. And we're in research, we had debrief day, and we got.
You should wait till I get like the art one. And then you can get the sports one.
Where is
Okay. If it's not on the circle, they just draw.
Like, if they're good. Okay. Have you ever?
I wonder how they made.
Is there a type of like Mandarin? Is it? I like it. No, it's just like a close to natural.
So that it's naturally. Has all the inside.
You know, obviously natural.
No, but like normal ones, you have to like cut through it.
Yeah, it's called a Mandarin. Like a Mandarin. I still don't like that.
But they don't like.
Yeah. We literally, like, I was fucking so dead. That's why I feel like. That's why she does not need me. She just going like at lunchtime. No, and I was really excited. And she's like, you have to find some internship. And I was like, you know I don't.
And I get art.
I didn't.
It's art.
It's number one. I'm not talking about it. But you're the first person to say that. I'm not.
Where's the Wendy's?
Wendy's is okay, so,
Oh, it is?
yeah, fast. I did
Yeah, I remember seeing the before, but I was like,
Yeah,
you never been to was there before the video? That is so exciting.
That's like a southern thing though, right?
Yeah, and it should be all over the place. Like, if you go anywhere outside of this area, especially north, like everywhere is like.
You're saying your second chance to get wrong.
Yeah, we do have one.
Okay, let me just go over the schedule for this week. I've had a couple of help sessions for the Chapter 5 recovery test, which will be tomorrow. So I had a help session Wednesday, Friday, and Monday, all in the mornings. I recorded all 3 sessions, and all 3 sessions are a different version of the test. So, watching those videos and preparing for your recovery test using those videos, I think could be helpful. The recovery test is tomorrow. You can recover up to 79. It'll be 7:15 a.m. or 3:30 p.m. So you have a couple options here. You can take this test, see how you do on this, and then take or you can decide that you want to take the Trig unit test and see, well, this is required, but the Trig unit test can replace the lowest test grade. So if this is good enough, you can replace the Trig unit test, the test, Chapter 5 test. Or next week, you come in and you take the Chapter 5 recovery test or trig recovery test or doing a makeup test. So next week is all just for makeup. Okay. What I'm thinking now is, for those of you who are considering that maybe you want to wait to take that Chapter 5 recovery test to see how you do, another option is you can take that Chapter 5 recovery test, and if you still don't do well on that, I'll let you take it again next week. Right, so now you have two tries to try to get it up to a passing or up to a 79, right? So, I'll do everything I can to, every opportunity that I can give you to try to move your grade up, but it does require some effort on your part to come in and prepare and try to get your grade up. Right, so this whole week we're just preparing for the trig unit test. I have the review worksheets that you guys picked up, and then there's 3 review worksheets, and I have solution keys to each of them. So if you're working ahead or working the problems that we skip in class, you can work through them and see your progress. Okay. Any questions about this week or next week? Okay, so let's look at test review worksheet 1. We're going to skip the continuity and limits, so that's not going to be on the test. We're going to go directly to number 2. Okay, number 2 says determine whether Rolle's theorem can be applied. All right, so Rolle's theorem. Our function is secant of x on the interval from negative pi over 4 to pi over 4. Okay, so find the values where f prime is equal to 0. Now, there are 3 conditions for Rolle's theorem. First is the function continuous? Is the function differentiable on the open interval? And also, we want to know whether the endpoints have the same y values. Okay, so let's test for continuity and differentiability. First, it's easier to think about secant in terms of cosine. So we know that secant is really the same thing as 1 over cosine. So cosine doesn't have any vertical asymptotes, but secant does, because whatever causes cosine to be 0 is going to cause the denominator to be undefined, or denominator to be 0, or in the expression to be undefined. So where is cosine equal to 0? Pi over 2, 3 pi over 2. Now, if we think about the negative regions, since our intervals goes to the negative, we can also say negative pi over 2 and negative 3 pi over 2, right? Just values around 0. Now, because these are values that causes cosine to be 0, these are also places that causes secant to be undefined. So what that means is we're staring at vertical asymptotes here for secant. Now, what we want to know is, just because we have asymptotes doesn't mean that our function won't be continuous. We just have to make sure that our vertical asymptotes don't interrupt our interval. Okay, so if I just put all this onto a number line just to help convince us. Here's negative pi over 4. Here's pi over 4. And then pi over 2 is going to be to the right of pi over 4. 3 pi over 2 is going to be to the right. Negative pi over 2 is going to be to the left. And negative 3 pi over 2 is going to be to the left as well. So our interval is from negative pi over 4 to pi over 4. Is there going to be any vertical asymptote that's going to disrupt our interval? No. So we're safe, right? So all the asymptotes that we found near 0, none of them will interrupt our interval. So we know our function is continuous on the closed interval. Now, if our function is continuous, it's also differentiable. So on the open interval from negative pi over 4. All right, so our first two conditions pass. We also need to determine if the endpoints are the same. So we're going to plug negative pi over 4 into secant of x and also pi over 4. Let's see what the y values give us. Okay, I'm going to think in terms of well, I'll think in terms of cosine, but I'll write that next. Okay, so cosine of pi over 4 or negative pi over 4 is the same thing as cosine of 5 pi over 3. That's going to be root 2 over 2. And if I flip that to make it come up to the numerator, that's 2 over root 2. Okay, so these are the same y values. So we know that Rolle's theorem will pass, continuity passes, differentiability passes, our endpoints are the same y value. So now we can guarantee that f prime of x must be equal to 0 somewhere along the interval.
Could I be funny? How much a bag in your bed there?
Okay, look for it. Okay, so now let's find f prime. Okay, so what's f prime equal to? Yeah, secant x tan x, right? Okay, we set that equal to 0. Now it's easier to think in terms of sine and cosine, so I'm just going to convert everything to be in terms of sine and cosine. We know secant is 1 over cosine. Tangent is sine over cosine. So if I want to find out where the derivative is equal to 0, do we look in the numerator, denominator, or both? Just the numerator. Okay, why just the numerator? Yeah, denominator is undefined. So we're looking for slope 0, not slope undefined. So slope 0 is just going to come from the numerator. So yeah, just numerator. Now, if it's critical points for slope sine line, then we look at both the numerator and denominator. But here, Rolle's theorem, we're just concerned about slope 0, but just the numerator. Okay, so where is sine equal to 0?
0, 2 pi.
I'm going to list out negative versions as well. Now, Rolle's theorem, we are only concerned about solutions that land between our endpoints. Do you see any that land between the endpoints? Between negative power 4 and power 4, it's just going to be 0, right? Because pi and 2 pi, they're all going to be to the left and to the right of our interval. So our only C value is 0. Okay, questions with Rolle's theorem, number 2. Yes. Go up.
I mean, down.
Okay. All right, let's look at number 3. Everybody good here? With 2. Okay, it's also in your packet too. The solution key is also in your packet. Okay, number 3. Apply mean value theorem. Okay, so mean value theorem looks a lot like Rolle's theorem. It's just that here's the formula. It's just that there's no guarantee that the endpoints have the same y value. So we may have a slope that's other than 0. Okay, but first things first, we need to identify, see if our conditions pass. There's only 2 conditions, differentiability and continuity. You know that your sine curve is not going to have any asymptotes, smooth all the way through. So it will pass the first 2 conditions without any trouble. Okay, so now we're going to spend the time to find the endpoints. Yes.
So if there's like nothing in the denominator, it'll always.
That's right, for sine and cosine. But for tangent, secant, cotangent, cosecant, they all will have vertical asymptotes.
Okay.
Right. Yeah. But yeah, sine and cosine, as long as there's no denominator, you're always going to have a smooth continuous curve. Okay, so now we have to go ahead and find the endpoints, just like how we did with Rolle's theorem. It's just that we don't have to have the same y values for mean value theorem. Okay, f of 0. Okay, sine of pi is equal to 0. Sine of 2 pi is also 0. So they end up being the same y value, but it didn't have to. Okay, so it looks like this would have fulfilled Rolle's theorem as well. But the idea here is the slope is still going to be 0 because change in y over change in x. So all we're going to do is we're just going to set f prime equal to 0. So let's find f prime. Right, so we have this piece of the formula, right? We have this being equal to 0. Okay, f prime. What's the derivative of 2 sine x? And then sine of 2x turns into, yeah, so cosine of u times u prime, right? Now the issue here is we want to solve, but right now we're kind of stuck in cosine 2x. It needs to be expanded out from double angle form. So we're going to use this formula here. Cosine 2x can be expanded into 2 cosine squared x minus 1. Okay, everybody good with this step here? Yeah. So this is a double angle formula. So cosine 2x can be expanded out to be 2 cosine squared x minus 1. So it's on your trig formula sheet. Yeah. Okay, let's do some cleanup here. I see exponent 2, exponent 1, and the constant. I'm thinking this is a factoring problem that I can apply. Take out a GCF of 2. Now this is a factoring problem, but maybe it's easier if you want to just factor an easier version of this problem. So imagine this is imagine just trying to factor 2x squared plus 1x minus 1. Right. If we factor this, then we can just bring the cosine back to into our factored form. Right. So multiplies to be a times c, adds it to be 1, a value 2 and 2. Multiplies to be negative 2 would be negative 2 and 1, or 2 and negative 1. Multiplies to be negative 2, adds it to be 1, 2 and negative 1, right? Two over 2 reduces. Force the denominator in front. Now that you have your factored form, let's bring that cosine back in. And now we set both parts equal to 0. All right, so where's cosine of x equal to negative 1? That'd be 0, right? Cosine of x equals negative 1 is just that pi, right? Okay. Where's cosine equal to 1/2? Pi over 3 and 5 pi over 3. first and fourth quadrant. Okay, so then we're only going to keep the values between 0 and pi because that's our interval. So the only solution we're going to have is what? Just pi over 3, right? Pi is outside it's right at the endpoint. The endpoint is not good enough to be inside the interval. 5 pi over 3 is definitely outside the interval. So only pi over 3.
How many questions is the test?
Still working on that. I'm not sure yet. Okay, let's go look at number 4. Okay, number 4, object's position. Object's position is given by f of t. Function is continuous and differentiable in the domain. Find the average velocity. So average velocity is just the change in position over change in time. We're not going to touch the velocity function. But let's rewrite this, make it easier to work with. Let's force that exponent outside. So the way we define average velocity is the change in position divided by the change in time. Okay, so we're just going to do f of 2 pi. It's asking from 0 to 2 pi, so we just find the position at the endpoint and divide it by the time interval. Okay, so let's find those two endpoints, f of 0 Okay, secant of 0, let's think in terms of cosine, right? What's cosine of 0? 1. And if I flip 1, because secant is the reciprocal, it's still going to be what?
1.
It's still going to be 1. Okay, f of 2 pi. Secant of 2 pi. Oh, I need to put this over 6, right? So secant of 2 pi over 6. Secant the power, this basically secant the power over 3. Secant the power over 3, think in terms of 1 over cosine of pi over 3. What's cosine of pi over 3? Right, it's 1/2, right? If you flip 1/2, it becomes 2. 2 cubed is 8. 8 times 2 is 16. So now we can find the slope, right? Or the average velocity. Change in velocity, change in position divided by the change in time. (16 minus 12, 16 minus 2 over 2 pi minus 0. And what does 14 over 2 pi reduce to be? Good, that pi stays in the denominator. Okay, so part B says, at what point in time does the instantaneous velocity equal the average velocity? So in other words, there's another way of saying mean value theorem. Derivative equal to the slope between the endpoints. So we have the slope between the endpoints, right? 7 over pi. We're just going to set the derivative equal to that, and then we can just set up the equation and not solve. Okay. So let's find the derivative. Okay, can you recognize what rule is required here if you want to find the derivative? Chain, right? So outside, inside, inner. Now t over 6, you can think of t over 6 as the same thing as what?
1/6.
Yeah, 1/6t. Maybe it's easier to think in terms of a coefficient in front of a variable instead of a coefficient under a variable. Okay, derivative. Yeah, outside's derivative first.
6.
6, yeah. Six parentheses squared. Okay, secant becomes secant tangent. And then finally, the innermost function's derivative, 1/6t, becomes just what? Just 1/6, right? 1/6, yeah. Okay, do a little bit of cleanup. The 6 and 1/6 can cancel out. I can merge the secants together. And then mean value theorem, we're just going to set the derivative equal to the slope. Yeah. Oh, yeah, 6 cancels out, yeah. Okay, part C just says find the instantaneous velocity at t equals pi seconds. So we have the derivative. We can just evaluate the derivative at pi, right? Yes. Oh, so what I did was there's two secants here, there's one secant here. These are like terms. I multiplied those together and I made a secant cubed.
Oh,
Oh yeah, this 7 over pi. That's saying that's coming from the average velocity, right? So mean value theorem is where we set the derivative equal to part A, the average velocity. Yes, we're not solving it. Okay, f prime of pi, we're just going to plug pi into the t's of the derivative. Secant of pi over 6, maybe it's easier to think in terms of cosine. Okay, what's cosine of pi over 6? And then tangent of pi over 6, 1 over root 3, right? Okay, so we're going to use this to help us find secant of pi over 6. Secant is just taking the reciprocal of cosine, right? Okay, so 2 cubed is 8. Root 3 cubed, the same thing as saying root 3 times root 3 times root 3. 2 of the root 3s will become 3. There will be a leftover root 3. So this is 8 over 3 root 3. If I multiply across, 8 times 1 is 8. 3 root 3 times root 3 is just going to be 3 times 3, which is 9. Velocity, so meters per second. Okay, part D, very similar. We're just now going to find velocity at a different t value, so f prime of 2 pi. But we're just entering it into okay, so now we can think in terms of cosine of pi over 3, right? You know cosine of pi over 3 is 1/2, so we can just flip that to get the secant. Tangent of pi over 3. Yes, it's root 3. So let's finish our evaluation here. Flip 1/2, we get 2. So just 8 root 3, right? 2 cubed is 8. All right, part E, equation of tangent line. So we'll just use the information from part D, right? All we need is order pair and slope. So tangent line equation comes from the ordered pair. We need ordered pair, so f of 2 pi. Secant of pi over 3. Take the 1/2 and flip it. Okay, we have our order pair. We have the slope from part D, and then we can do point slope form. Okay, we're just going to start worksheet 2. Next page. Yes.
Up to read like the notes about what like the exactly was going on.
For D,
Could be.
B, okay.
It might be a little higher. Like said like how to find the.
Oh, chain rule here? Is that what you're asking about?
No, it was like you said like it equals something else. It was like.
Oh, right. So this is a mean value theorem. We set the derivative equal to the slope between the endpoints. Mean value theorem. Is that where you're?
Oh yeah.
Okay, worksheet 2. number 1, it says, this is just solving a trig equation, but I think it's good for us to practice this from last year. We're going to find multiple solutions without having to expand out of double angle. So okay, solve for x. We want x to be between 0 and 2 pi. So here's one strategy that we can do rather than expanding this out into 2 cosine squared x minus 1. Just think in terms of inverse. Okay, so first thing we do is let's try to get 2x by itself. To get 2x by itself, we have to move cosine. When we move cosine, we are essentially doing inverse of both sides. Right, we're just taking the inverse of both sides. The left side will go away, leaving us with just 2x, and the right side is inverse cosine of 1. So this looks a little strange, I know, but inverse cosine of 1, another way you can think about this is asking yourself, when is cosine of theta equal to 1? These mean the same thing. All right, so when is cosine of theta equal to 1? Okay, 0 and 2 pi. Now here's the thing is that we're going to have to list out more than what we think we need, because ultimately all these values are going to shrink because we're going to divide by 2. So we're going to keep going. We're going to extend out further than what we think we need. So we're going to keep finding coterminal angles. We're going to keep adding 2 pi. So 0 plus 2 pi is already 2 pi. Okay, what's 2 pi plus 2 pi? So we're going to keep going. I don't have to worry about the negatives because I'm only going to go from 0 to 2 pi. So I'm going to replace all these values for cosine, inverse cosine of 1. Okay, we're going to see all these values shrink, and once they shrink, we're going to pick all the ones that fall between 0 and 2 pi. So dividing by 2 is same thing as what? Multiplying by. Okay, so right now it doesn't seem like a big deal, but when the right side are a bunch of fractions later on, it's always good to think in terms of multiplying by the reciprocal, just a little cleaner that way, rather than trying to, you know, divide fractions in your head. Yes.
How did pi get in there?
Oh, I'm sorry. Yeah, it should just be from 0. I'm jumping ahead there. So it should be just 0, 0, and 2 pi. Okay, so multiply everything through by 1/2. 0 times 1/2 is 0. 2 pi times divided times 1/2 will be pi. Right, 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So now we have our solution set, but we only want to keep what's between 0 and 2 pi. So the only x value is what? Just pi. Okay. Okay, so now you see how we're going to approach these problems. Let's try number 2. Okay, we want all the, ultimately at the end, we want all the solutions between 0 and pi. But you see that 4x is going to cause all of our angles to shrink even more. So let's take the inverse of both sides. Inverse tangent of 1, another way to think about this is asking ourselves, when is tangent of theta equal to 1? Pi over 4, okay. That's first quadrant. What other quadrant is tangent equal to 1?
Third.
So what's the variation of pi over 4 in the third quadrant? Now we have to find coterminal angles because all these are going to shrink. So we're going to add 2 pi. But maybe just move things a little bit faster if we can just think in terms of common denominators. Same thing as saying adding 8 pi over 4, right? Because my denominator is already 4. Okay, so let's find additional coterminal angles because we know that there's going to be a lot of shrinking with these values. Okay, so what's pi over 4 plus 8 pi over 4? 5 pi over 4 plus 8 pi over 4? Okay, let's keep going. So 9 pi over 4 plus 8 pi over 4. Let's do one more. 13 plus 8 Okay, so these are all the possibilities. We'll put them on the right side. Dividing by 4 is same thing as 1/4. So we see here now the benefit of multiplying by the reciprocal is going to be a lot cleaner, right? Just multiply across rather than dividing by 1/4. Okay, look at all these fractional values. We only want values that are greater than 0 but less than 1 pi. So do we have any of these that we want to eliminate? What's outside the interval? What's greater than 1? Yeah, 17/16 is slightly greater than 1. 13/16 is still less than 1, so we want to keep it, but once you get past it, so it's good to have too many solutions because you can have reassurance that you've covered everything, right? You've cut something off, so rather than listing out, if you don't know, if you don't cancel out one, at least, you know, you're always thinking, wait, maybe I missed out on something. But here, there's that extra assurance or reassurance that you've covered everything because you're working all the way to a point where you can eliminate one. Okay. Okay, so we make good progress today. We'll continue with worksheet 2 tomorrow. If we get done with worksheet 3 early, then I'll pick out some more problems for us to work on before Friday's test.
You know,